Because this week I won't be able to offer a live session that reviews the practice quiz 12.3 for lessons 12.1 through 12.3, I'm making this recording so that after you've taken the practice quiz, you can review the answers and the reasons behind the answers. So let's get started. In each of these questions here, you're asked to determine if the following measures could be the sides of a triangle. If so, classify the triangle as right, acute, or obtuse. So there's two questions here. First of all, are they the sides of a triangle? Which means, that I have to make sure that, if I add two of the sides together, I'm getting a value that's more than the third side. And usually it's best to choose the two smaller measurements and then see if it adds up to be bigger than the bigger side. That's typically the way to go about doing that. Now, as far as right, acute, or obtuse, since we don't have any angle measurements, we're going to be using the Pythagorean theorem and some of the theorems that come from it, which basically says if it obeys the Pythagorean theorem, these three sides, then I could say that it's a right triangle. If I add the square of the two smaller sides together and get a value that is bigger than the third side squared, that's a sign that it is an acute triangle. And conversely, if I add the square of the two smaller legs together and get a sum that's less than the square of the third side, that's a sign that I do have an obtuse triangle. So when you're asked these various questions on the practice quiz, those are the kind of ideas they wanted you to run through to make your decision. So for this one here, I'm choosing the biggest side to be 80. I can see that 20 and 78 added together is certainly bigger than that, so it definitely is a triangle. 80 squared is 6,400. When I do 20 squared plus 78 squared, I get 6484. So, the Pythagorean theorem isn't being followed. The smaller two legs, the sum of their squares is bigger, so that's an acute triangle. When I look at B, again, I'm focusing my attention on the biggest side. I can see that the two other sides of the triangle end up being bigger than that third side, so it definitely is a triangle. When I do 24 squared, I get 576. When I do 11 squared plus 14 squared, I get 317. So the third side is certainly square. I mean, the bigger side squared is more than the sum of the squares of the two smaller sides. That's a sign that it's an obtuse triangle. 5 meters, 12 meters, and 13 meters. Again, I'm focusing on the biggest side. When I square that, I get 169. When I do 5 squared plus 12 squared, I get 169. The Pythagorean theorem is being followed here, so this is a right triangle. I didn't comment before about the triangles being being a triangle first, but sometimes if you try one of these rules out, it's if it obeys the Pythagorean theorem, it's going to be a triangle as well. If you're using one of the other rules right away, that you have to be careful about that. For D, I'm focusing on the 12 millimeter size being the biggest side. When I look at the two other sides, I add those together, I do get 13 millimeters, which means that this is a triangle. So when I square 12, I get 144. When I do 2 squared plus 11 squared, I get 125. Which means that the biggest side of the triangle, when it's squared, it's bigger than the sum of the squares of the two smaller sides. Again, that's a sign that this is an obtuse triangle. When I deal with 6, 10, and 17, 17 is the bigger side. When I add 6 and 10 together, I get 16, which means I have two sides of the triangle adding up to be smaller than the third side. That can't happen inside of a triangle, so this triangle doesn't even really exist. So, in the last one, when I look at the 97 yards as being the biggest side, 65 and 72 is certainly bigger than 97. When I compare 97 squared, which is 9409, and 65 squared plus 72 squared, I get 9409. That means that the sum of the squares of the two smaller sides equals the square of the larger side. It's obeying the Pythagorean theorem, so this is a right triangle. This next question, they were giving you, this figure here, a right triangle, and you had the sides being labeled as 7, 24, and 25. They wanted you to state what the sine of cosine and tangent of A are, as well as the sine, cosine, and tangent of B. You have to remember that when we're using these, when we say opposite over hypotenuse, adjacent over hypotenuse, what we call the opposite leg and the adjacent leg are subjective to which angle we're focusing our attention on. Some students make the mistake, they'll say like 7 is always going to be the adjacent side because it's horizontal. Well, it doesn't say horizontal side over hypotenuse and vertical side over hypotenuse, because a right triangle doesn't have to have, any sides that are vertical or horizontal. So, it certainly is possible to not have legs that meet those criteria. So I have to make sure it's always opposite leg and adjacent leg. And of course, that's going to be subjective to which angle I'm talking about, because when I look at, like, for instance, angle A, its opposite leg is 24, where I look at angle B, its opposite leg is 7. So when I use the definitions of the trig functions, the sine of A, when I look at A and focusing my attention on A, AC is the adjacent leg, BC is the opposite leg. So when I do opposite over hypotenuse for sine, I get 24 over 25. When I do the cosine, I get 7 over 25. When I do the tangent, I do 24 over 7. When I move on to angle B, this changes, because now AC is the opposite leg, BC is the adjacent leg. The hypotenuse still remains the hypotenuse, because the hypotenuse is always opposite the right angle. So now when I apply the definitions of sine, cosine, and tangent, I'm going to get 7 over 25 as the sine of B, 24 over 25 as the cosine of B, and I'm going to get 7 over 24 as the tangent of B. Always keep in mind that the sine of x and the cosine of x are always less than or equal to 1. If you are stating a value that's 1 or more, or actually more than 1 for those two, then you are misinterpreting something. That's another sign that you're doing something incorrectly with that. So keep that in mind as you're doing the work for this as well. Sometimes you can catch a mistake just by looking at that. For this one here, they want you to find the values of x and y. Now, I could use trig functions for this, and you're certainly welcome to do so, but this is a 30, 60, 90 triangle. So we should know that, these sides, x and y, should, have a certain relationship with the 16-foot side, which is the hypotenuse in this case. I do know, that the three sides of a 30, 60, 90 triangle go with the shortest side, which is what y is. X should be the square root of 3 times y, and the hypotenuse, which is currently 16, is 2 times y. So knowing that 16 is 2 times y, I can say that s is 8, which means y is 8 feet, and which means that x, which should be s times the square root of 3, is 8 times the square root of 3 feet. And that's all I really need to do for this one. For a 45, 45, 90 triangle, I know that A and B are legs of this 40, and I know the other angle is 45 degrees because they have to total 180, and the only way for this to happen is for the other angle, the missing angle, to be 45 degrees. I do know that the 10-inch side, because A and B would be the legs, are the shortest sides of the triangle, so they would be in the ratio, in the formula we use, they would be called S, and the hypotenuse is S times the square root of 2. So, if I solve the equation s times the square root of 2 equals 10, 10 divided by the square root of 2, which is a suitable answer, but keep in mind that they'll always put it in, or sometimes they'll indicate that they want you to put it in simple radical form. Simple radical form does not allow radicals in the denominator. So I would need to multiply this by square root 2 over square root 2. I would get 10 square root 2 over 2, which is 5 times the square root of 2. And since that's what S is, and A and B both equal S, that's what A and B would be in inches. For this one here, now notice we do have a 36-degree angle, so this is not a special right triangle, so I'm going to have to use either trig functions, Pythagorean theorem. I'm looking for a side measure x, so, the Pythagorean theorem would be a good one to look for, but, I'd have to know two other sides of the triangle. Currently, I only know one additional side of the triangle. So Pythagorean theorem is out as far as that goes. So I'm going to have to use a trigonometric function to solve for this. So when I look at the circumstance here, I do see I have the 36-degree angle is the angle I do know. X is the leg opposite of it, and I do know the hypotenuse. So those should be the three things that are involved in the trig function. Since I'm using the opposite in the hypotenuse, I should be using a sine function. So I did say all this stuff before. So the sine of 36 degrees is going to equal x over 15, which means that x is going to be 15 times the sine of 36 degrees, which means x is approximately equal to 8.816. And since there were no measurements or units given, I don't have to give any in this particular problem. They did say round to the nearest whole number, so the final answer would be 9 in this case. So same thing here. You're asked, to find the value of x. X here is an angle measurement, so, and we also want to round our answer to the nearest whole number. I know I have the 90-degree angle. The other missing angle I know along with x should total 90. That doesn't help me figure out what it is, though, because I don't necessarily know if they're equal or what proportion they are to each other. So I can't just simply go and say, okay, well, that's going to be this angle measurement here. I am going to set up a trigonometric function to figure this out. With this angle, I have 11, which is the hypotenuse, and I have 9, which compared to this angle is the adjacent leg. Since I'm talking about using a trig function involving x, the adjacent leg, and the hypotenuse, I'm going to be using cosine. So the cosine of x degrees equals 9 over 11, which means that x degrees is going to be the arc cosine of 9 over 11, which means that x degrees is about 35.0968 degrees, so we round out to about 35 degrees. Since they're looking for the value of x, and they already say that x is in degrees, x itself is only about 35. So for this one here, again, I'm looking for an angle measurement involving x. Again, I do not know the other acute angle in this right triangle, so me adding them up to 180 is not going to help me. I can see that the two legs are of different sizes. I mean, the fact that the two legs are of different sizes tells me that these two angles are not going to be the same measure. They're pretty close in size, so I wouldn't expect, x and the other missing angle to be too far away. But that's not good enough for me to get a good guess as to what the angle measurement here should be. So what I need to do is figure out, well, how am I going to determine what x is? Well, I'm going to need to use a trigonometric function again. So what I do have is I have the leg opposite of x, and I have the leg adjacent to x. And since that's the information I have, I know I need to set up a trigonometric function. Again, this is not a special right triangle, because I don't have any congruent sides. I don't have, I know that 16 is not 15 times the square root of 3. It doesn't have any of those ratios that are involved with special right triangles. I'm going to use a tangent function because it's opposite over adjacent. So the tangent of x degrees is 16 over 15. You have to make sure you set up the fractions correctly, too. You just can't involve the two sides and put them in any old order and expect it to work right, because it's not. Of course, to find x now, I'm going to do the arctangent of 16 over 15, which gives me about 46.8476 degrees, which means x is about equal to 47, because, again, it's x degrees, so we're talking about this angle being 47 degrees, which means the other one's 43 degrees. So, again, they're not that far away from each other as far as measurement goes, but they're clearly not equal. And that is the end of the review of this practice quiz. If you have any further questions, please make sure to contact me or one of your teachers. Until I get to see you in a live lesson, or if you're one of my students, I get to talk to you on the phone, I'll see you around. Have a good day.